Okay, so today I want to take you through linear modeling. So linear modeling is a term that we use to represent, when we're using a graph to represent real life situations. So linear obviously means straight line, and modeling means we're representing something. Okay, so it is just a matter of taking a worded problem, finding the important information in that and converting it into a graphed equation. Okay, so let's have a look at this problem. Carla has a window cleaning business. Each day it costs her an average of $75 for fuel and vehicle maintenance, and it also costs her $8 per job. So that's going to be like using her equipment. Okay, so we're going to let C be equal to Carla's daily cost, usually C for costs, okay? And N is the number of jobs per day. So that's a really, really common thing to use, is N for the number of whatever things that you are talking about, and C for the cost. So we want to write a linear function for Carla's daily cost. So remember, a linear function is just a really fancy name for an equation. Okay, so we want to know what her costs are equal to. So her costs are equal to, each day it costs her $75 for fuel and maintenance. So every day costs her $75, plus then it costs her $8 for every job that she does. So remember, we're using N to represent the number of jobs. So it's going to be 75 plus 8 times N. And of course, we want that written in a familiar format. So we're just going to simplify that, clean it up a bit, and rearrange it. So we'll have C is equal to 8 times N is obviously 8N plus 75. Now, the reason I have swapped the position of 8N and 75 is just so that it is in our gradient intercept form. So remember, our gradient intercept form shows us the slope of the line, which is the coefficient of n or x, and our y-intercept, which is our constant value. Okay, so then we are asked to construct a graph to illustrate Carla's daily costs. On my grid, I have a nice handy table of values. I'm going to write my equation at the top. C equals 8N plus 75. Okay, and then I'm just going to choose appropriate, in this case, N values to represent the number of jobs. And then instead of Y, we're going to have C, which is our cost, how much it costs her to do those jobs. Obviously, she can't do a negative number of jobs, so I'm going to start at 0, 1, 2, 3, 4. Keep it really simple. Okay, so when she hasn't done any jobs, it's going to cost her 8 times 0, which is obviously 0, plus 75. So no jobs, it's going to cost her $75. Okay, one job is going to be 8 times 1 plus 75, which of course is 83. All right, so we can see we're going up by 8 because our N values are going up by the same amount each time. That means our C values will also go up by the same amount each time. And if you happen to notice, our C values are going up by 8, which of course is the coefficient of N, which is, as I mentioned earlier, the gradient. Okay, super duper important to remember. Okay, so I'm just going to fill in the rest of my values. So 83 plus 8 is 91, 99, 107. Okay, they're not the nicest numbers for me to graph, but I'll do my best not to stuff it up too much. Okay, so 0 is 75, so that's going to be obviously halfway there. 3 is 99, which is pretty close to 100, so I'm going to make it there just for ease of graphing. Okay, I'm going to join those 2 points, doing my best with my dodgy ruler. Okay, So there is our graph. Now obviously we could have chosen different cost or C values to have a flatter line, but that is okay. Okay, so what is the gradient and vertical intercept, and what do these values represent? So I gave you a little clue about this before. Okay, so because we've written our equation in gradient intercept form, okay, we can read straight off our equation that the gradient is 8 and the y-intercept is 75. Okay, so what that means is, we'll just get that down. So our gradient is 8. Remember, we use m to represent the gradient, and our y-intercept is our constant value in our equation, which in this case is 75. So what do these represent? The gradient represents the costs per job. Okay, so that's costs per job. So you can think of that like a rate. And the vertical intercept represents the fixed daily costs. So no matter how many jobs Carla does, it's going to cost her $75. So obviously she is going to be better off doing more jobs in the day, okay, because she's not going to start making money until she has made more than $75. Okay, hopefully that's helpful in modeling real life situations. Give it a like if it was of any use to you. Remember, you can also comment below if you would like to make any specific videos, and I will do my best to upload them.